Hey. All right before lunch, we did our division. You guys good with that stuff? Nobody lost that over? Nobody lost any of those brain cells over lunch? Okay, we're not gonna keep moving through this. We're gonna keep touching back to this division. If you turn your paper over to the next sheet, it says, find the remainder two ways, okay? Would you rather do long division or synthetic division? Anyone have a preference? Synthetic, right. We'll do synthetic division for one, and then they'll show you another way to do the second one. So the first way we'll do synthetic, or again, if it makes you happy, you could have done long division. 1, 5, -8, 3. Carry my 1 down. Okay, so that's -1, which is 4. Set -4, -12, +12 becomes 15. Okay, what there is my remainder? 15, good. So using synthetic division or long division, we could have divided it all the way out, and then the last thing we got is the remainder. So 15 is my remainder. All right, there are two theorems in math that we're going to talk about right now. One is called the remainder theorem, one is called the factor theorem. I will not ask you what their names are, but it's like a fun idea or concept to know. So the idea of the remainder theorem is if you plug in the number that I asked of you, if you just plug that into all of my x's, then that will give you the remainder out. Let's see if I want to write it like kind of fancy, the remainder theorem says something like this. It says like if, like we'll say x, we'll even just use the example we have. If x plus 1 is, I don't know, is divided by, I guess that's the word we can use because I want to use the word factor, but it's not, is divided into f of x. Then when I plug -1 into my function, we're going to get out the remainder. So all I'm saying is if I take the number that they wanted from me and I plug it in instead of doing long division or synthetic division, that's the same thing as getting the remainder. Now, a caveat to that is called the factor theorem, which is actually really nice. It's if we're not just dividing, but if we know that f of x plus 1 is a factor, then its remainder should be 0. So then if I plug that in, if I were to plug my -1 in, if it was a factor, sorry, I know my pen's being really weird today. If I plug -1 in, I would get out 0. So if we ever have this case where you plug a number in and we get out 0, then we know that that number is a factor. It's a 0. It's the root on my graph. And so we're just going to actually put that into practice. We're just going to plug it in. So I'm going to take -1 and plug it in for all my x's over here, and I should get the same thing as 15. So if I do
positive one?
No, -1. I'm
Still
gonna still just gotta flip it. I'm gonna do -1 to the third plus 5 times -1 squared minus 8 times -1 plus 3. And you can plug that in your head, or you can write that out and then do the rest in your head. I can't do all that in my head, so that's gonna be -1, 5 times -1 to the squared. We have to square first, that's just +5. -1 times -8 is +8, and then plus 3. And -1 plus 5 is 4, 4 plus 8 is 12, 12 plus 3 is 15. Perfect.
So is the number always -1?
Not always -1. I just put an example in here. You could have just used the example like x minus k or something to have like a variable there. But sometimes I feel like we do better when we have actual numbers. So in this case, it was -1. because this was what was given to me. But soon we'll try different numbers and see if they work. Okay? So we're gonna actually go back and we're gonna go to number 2, F and G, which you guys actually did at the beginning of class on the calculator. And we're gonna do this remainder theorem. We're gonna plug one of the zeros that we know into the equation and then see if we can find the other zeros from that. So let's go back in our notes to 2F and 2G. That was these problems right here. And I'm going to use the example of 1. I'm going to use 1 as my example. So we're going to pretend like we were given that 1 was one of my zeros and we want to find the other ones. So I can plug 1 in for all of my x's and then see what happens from that, see how else I can move from there. We decided we couldn't factor, we couldn't do anything else. This is the only best way, is if I know, okay, we know x is going to be 1. So we'll plug 1 in for all my x's. I'll do 1 to the 3rd. Minus 7 times 1 squared, minus 49 times 1, plus 55. 1 to the 3rd is 1, minus 7, minus 49, plus 55. Minus 1, minus 49, plus 55. That equals 0. So that's a good check. We did. We could do -5 and get the same thing and 11 and do the same thing. Let's just do one of them for letter G. Which one do you want to try there? -6, 2, or 8? 2. Perfect. Let's try the easy one. So that's 8. 2 squared is 4. 4 times 4 is 16. 44 times 2 is 88. So plugging in, you might be like, these are some crazy big different numbers, but 8 minus 16 is -8. Minus 88 is -96. And then I add 96 and I end up 0. All right, cool. Okay, we could go farther with those two, but we're going to go farther on the next problem. So we're just going to go back to where we were. Bless you. And numbers 5 says find all of the zeros, and it says find them exactly. It doesn't give us any hints. It doesn't tell us what to divide by. It just says find all the zeros. Okay. I'm going to give you some steps that like a general flow chart I follow, but all of these are a little bit different. So we kind of have to use our understanding to see if should we try something or should we try something else. So the things I would try, I'm just going to write try because that's what we're going to do. The first thing I would try to do is try and factor something down. Can we take a GCF out? Can we do a grouping? Can we actually just factor it as a trinomial? The second thing, I haven't taught this to you yet, but I will teach it to you in a second. Find the PRRs. Find the possible rational roots. Does that stir anything in your brain? Possible rational roots? Yes, no, maybe? Okay, not getting any response, so that's a no. That's okay. I'll figure it out. And then after that, I would try to synthetically divide. Most of the time, once we've done that, if there's still more to go, then we kind of come back to the top and start again. Try and factor again. Try and PRR again. Try and synthetically divide again. Okay? The first one is going to be a nice, easy factor one. So it says, find all the zeros, and it doesn't tell us anything else. And the first thing we always try to do is say, can we factor? So I'm going to go over to letter A. I believe we can factor this. How do we want to factor this out? Grouping, good. We'll do our grouping. So I'm going to take out an x squared. So I get 2x minus 3. And I've got -4x plus 6. I can take a -2 out of there to get positive 2x minus 3. Remember, with grouping, the insides have to be the same. Then x squared minus 2 is its own factor, and 2x minus 3 is its own factor. And then we can set each of those equal to 0. X squared minus 2 equals 0. You just add the 2 to both sides. Okay, perfect. Square root. Do not forget that's got to be a plus or minus root 2. On the other one, I'm going to add 3 to both sides and then divide by 2. X equals 3 halves.
Did you not factor down the, oh wait, just kidding.
Look to factor as much as possible, and if we get to a fault, like a stopping point like this, then we bring it all the way to here. And so all of my zeros here are plus or minus root 2 and 3 over 2. And so we can even make a list back at the top to put all the zeros together. It will seem silly on this one, but the next one it'll make sense why I kind of have a separate list in addition to my whole problem. So those are all my zeros. And we were actually able to do this really easily with just our factoring. Okay, now I did write something on the last one that we haven't talked about yet, but I know that we will need this next time. Any questions yet on letter A? Okay, letter B, I can't factor this by grouping. Yeah, I could group these guys and I could take out a common term, but like I don't have that overlap that happens with this negative 2x minus, or this 2x minus 3, so I cannot factor this. So the next option I have is what we call the PRRs, and I'm just going to write about them right in here. PRRs means possible rational roots. It doesn't mean that they're all going to work. It means that they are all possible. Rational, remember, is a type of number that can be written as a fraction. So my possible rational roots are going to be plus or minus p divided by q. We use p's and q's kind of like whenever we feel like it. What the p means here is the factors of the constant. So the number at the very end. So in R, like letter B, negative 6 is my P. I want to list all the factors of the constant on top. Q refers to the factors of the leading coefficient. Often it's 1. So that makes it a little bit easier. We don't get as hard as we could get here. And we keep it simple by having it just be the factors of the leading coefficient. Whatever the list of these like factors are my possible rational roots. And we use the factor theorem to decide whether they work or not. Okay. It's not a lot of work for this. Well, it could be not a lot of work for this if you can find it right away, but sometimes it takes us a minute to figure out which one actually works. Okay, so let's go like do an example of this, right? This seems all fun and games, Miss White, but like I don't know what's going on. So like let's put it in action. So I told you my possible rational roots is going to be my list of my factors of the constant divided by the list of the factors of the leading coefficient. So my factors of my constant in this case are going to be 1, 2, 3, and 6. So those are all numbers that multiply to be 6. 1, 2, 3, and 6. divided by the numbers that multiply to be my leading coefficient. Well, I don't really have a number up front. We assume that it's 1. The only number that multiplies to be 1 is just 1. This list now says, and I can just simplify it, I just can do all of these numbers divided by 1, which just means that they're all going to be whole numbers. That means that one of these or many of these could work. My possible rational roots are +1 or -1, +2, -2, +3, -3, or +6, -6. We want to plug these into my equation to decide if they work, and I know they work if I get out 0. I know they work if I get out 0. Now, I'm not going to make you try all of them just for time's sake. We'll practice plenty of that later. I'm going to tell you right now that the one that works is going to be -3. Let's confirm that it works. So let's use the factor theorem. Remember, the factor theorem says I'm going to plug -3 in for all of my x's, and I should get 0 at the end. That should confirm. So I'm going to do -3 to the third plus -3 squared minus 8 times -3 minus 6. I already told you this should work, so we should get the right answer. -3 to the third is -27. -3 squared is going to be +9. -8 times -3 is +24, and then we're going to minus 6. So if I do -27 plus 9 plus 24 minus 6, I get 0, so that's good. I didn't know what the factor was earlier, so I had to check 1 and -1 and 2 and -2 and 3 and -3, and then finally I found it. So I didn't make you guys go through that, but you might have to. It's
So we'll have to do that for like all 8 of them.
not all 8 of them. You hopefully find one pretty quick. So I'm gonna make us do it on the next one because you'll find it in one of the first couple. But if I think it's gonna be like hard or too time consuming, I will give you the one. So this one I just told you it is going to be -3. So that's one of my zeros. Now, I don't know what my other zeros are though, so we need to figure that out. So we just did put PRRs, our possible rational roots. Now I want us to use that root that works, -3, and do synthetic division and see what I get after that. Because we should be able to factor that or do quadratic formula or something to that in order to get my final zeros. So we had to check to see -3 worked. Now we're going to use it for synthetic division. So I'm going to go 1, 1, -8, -6. So that becomes 1, -3, 6, -2, +6, which is 0. If I already told you -3 works, you don't actually have to do the factor theorem. You could just prove that it works when you get 0 as your remainder here. But some people like to think it's easier to plug in instead of doing like 7 different synthetic divisions. So either way works, and you'll see for sure when I get my 0 as my remainder. Once I did that, now I'm left with, when I took out my -3, my x equals 3, I have x squared minus 2x minus 2. We should still have at least 1 or 2 more zeros, and so we aren't done yet. Remember back on this one how I told you we got to synthetic division, then we come back to the top and like try again? Now I'm going to go back to the top and be like, can I factor this down again? I can't factor this, but this does look familiar. We're really good with quadratics. I could do quadratic formula here and find the right answer, right? We're going to do that instead. So I'm going to write next to factor. You could also think about, can I do my quadratic formula? Because that's, for us, just as good of a tool as factoring. And remember the directions here, we're find all zeros. So we're not done until we find all the zeros. So I'm going to do quadratic formula for this guy, and that should get me all the rest of the zeros. So x equals +2 plus or minus root -2 squared minus 4 times 1 times -2 all over 2 times 1. Everybody okay with what I've done so far? Okay. So I get 2 plus or minus, that becomes 4. And then negative 4 times 1 times negative 2 is going to be positive 8 over 2. Which is going to be 2 plus or minus 12 over 2. We can simplify root 12.
I thought it was negative 8.
There's a negative in front of the 4 there, and then the 2 is
Oh.
negative 2. Mhm. So you can think of it as minus negative 8, but it will become plus. Root 12 is the same thing as 2 root 3, right? And then I've got all those 2's I'm going to cancel out. Two. Your final answer, as much as you want it to just be plus or minus root 3, it's going to be 1 plus or minus root 3. Don't lose the 1 right here. You don't need the 1 in the denominator or in front of the root 3. That's kind of redundant. We assume that it's there, but you can write it if it makes you happy. Okay, so my zeros for this one were negative 3 and were 1 plus or minus root 3. So I can even write that off to the side. X equals negative 3 and 1 plus or minus root 3. So I don't think these are necessarily like mathematically hard. It's just a lot of steps to keep in order and keep track of. All right, we're going to do another one a lot like that. You guys ready? All right, I would ask myself first, can I factor this big, long, crazy thing? My answer is no, I'm not equipped for that. So let's do our PRRs. Let's find our possible rational roots. Do you remember what factors go on top? Say again, Mark. Constant, good. So we'll say plus or minus, we'll say 1, we'll say 2, we'll say 4, we'll say 8. Those are all the things I can think of to multiply to be 8. The bottom is the factors of my leading coefficient, and what's the only number that goes down there? 1. Good. I know it seems redundant on these last couple. You're like, well, Miss White, why do we have to write that? Because it's all the same as on top. Because in a little bit, I promise we're going to start putting numbers out front here. And then we won't just have 1 on the bottom. We might have like 1 and 2. So we're going to have fractions that we might need to check too. So we're just starting easy. But that means I'm going to have positive or negative 1, 2, 4, and 8 are all possible rational roots. Now, I'm not going to tell us which one works here, but I'm going to tell us that we're going to find it pretty quickly. I always start small. So I'm going to try 1. I'm going to plug 1 in for all my x's and see if that works. If that doesn't work, then I'm going to try negative 1. If that doesn't work, then I'm going to try 2. So start as small as possible. Don't jump to 8. I promise 8's like highly unlikely to work. So let's do 1 and then negative 1, and then hopefully we'll found it. Again, you don't have to write the little work off to the side, but like if you want to prove to me why you know it, I have to keep it straight in my head, so I write it off to the side. All right, 1 to the 4th is 1, minus 3, minus 6, plus 6, plus 8. That will not work. I don't think that would be 0. Negative 8, it'll be 6. So that one does not work. So I'm going to try negative 1. We're just plugging, chugging, guessing, checking. Haven't done that for a while, but it's okay. Negative 1 to the 4th is 1. Negative 1 to the 3rd is negative 1. So negative 1 times negative 3 is a positive 3. Negative 1 squared is positive 1. Positive 1 times negative 6 is negative 6. 6 times negative 1 is negative 6, and then plus 8. What do we get? 1 plus 3 is 4. 4 minus 6 is negative 2. Negative 2 minus 6 is negative 8. Ooh, plus 8, perfect. I got -1 to work. Anyone not get -1 to work? I just would be really careful about your parentheses, about your negatives, about your distributed.
We want to equal
0. So when I say it works, it means I got 0 and I said, okay, great. So that means one of my zeros is -1. Once we find a PRR that works, then we're gonna use synthetic division in order to figure out what happens as I go down a step. So I'm gonna do -1 in my little box, and I'm gonna have 1, -3, -6, +6, +8. See what happens when we divide out this -1. Again, you can use synthetic division instead of the factor theorem where you plug it in. Either way, I got my remainder to be 0. So my new equation is x to the third minus 4x squared minus 2x plus 8. So the steps that I said on the side, we tried to factor, we couldn't factor it, so we did our PRRs and then we did synthetic division. Now we jump back up to the top. Can we factor or quadratic formula this? I think we can factor this one, right? Factor by grouping. I think if we group these two together and then the other two together, I think it should factor pretty nicely. And actually, I like factoring better anyway because it gets us our answer a little bit quicker. So let me rewrite it up here so I've got more space. X to the third minus 4x squared minus 2x plus 8. So that gives me x squared, x minus 4, minus 2, x minus 4. Okay, perfect. It's going great. And then since we factored it, it's working out so nicely, let's set those factors equal to 0. And those will be my final zeros. And then the only other thing is I need to remember x equals -1. That was one of my zeros from a long time ago. So I'm going to bring that over here with all the rest of my zeros. So I got 2 from factoring, 1 from possible rational roots. Grayson?
You should add the 1 or the plus minus.
Not on this one because we added the 2 over. We don't have a 1 out front. Because I wasn't adding or subtracting to that. That only was with the quadratic formula because I canceled the 1 out front of that. All right, that seems good. I will make a little tiny video to go over upper and lower bounds for you to watch. I don't see you guys tomorrow, right? You guys watch on Wednesday in addition to your practice. If you get done with your practice, you can work on all your homework. And then I will do part of or all of 2.5 for the last day of the week that I'm supposed to see you. Cool? Oh, good. Perfect timing. I know, we were moving. We had a lot of good work today. Oh, Lucy, to come back to this, we did not talk about this, so if you want to turn your homework in without it, since you are going on retreat, if I make a video, it'll go online and we'll talk about it next week when you come back. How was your trip? Where'd you go?
Should I just send you my?
That's fine.
I can't really find the resume.
That's really fine. Just send me that.
I would never.
Just email it back.
Just email it to me.
So G's like, Mr. No's like, Dr. Science.